So say that I knew that f of x is equal to the square root of x, and I knew that f of 9 is equal to 3, right? The square root of 9. Well, with this information, can I pretty much guess what f of 10 would be? Because f of 10, well, we don't really know what this is. The square root of 10, we don't exactly know how to define that, other than using the radical symbol itself. But this is a number. This is something, point something, something, something. So how do we come up with a guess? This is what we're going to be discussing today, and it's the method of linear approximation. Here's how it works. Say you have the function f of x is equal to the square root of x, which looks something like this. Okay? Now, let's say this is 9 and this is 3. I know this. Or sorry, this I meant to say this is 3 and this is 9. Apologize. Well, using this information, f of 10 is right around here. I'll label this in red. They're pretty close to each other. Now, this doesn't mean that we're going to use this as the guess. F of 9 and f of 10 are certainly not the same thing. So, but what about the derivative? Well, the derivative at f of 9 tells us the slope of the tangent line at that point by the dotted line. So right there, you can see we can pretty much use the tangent line right here. This point right here, the derivative at this point, I'll label that part in yellow right here, to pretty much guess what the actual point would be. So there's an error that's true, and this yellow bracket I've shown you here is how much we're off by. But it's a pretty damn good approximation because the closest point we know, which is f of 9, which gives us 3, right, of the y value, we can use that, and we can use the tangent line at that point to pretty much guess what f of 10 would be over here. And this is exactly what we're going to be doing. So let's take that same exact example. So we know that f of x is equal to the square root of x, okay? And we know that f of 9 is equal to 3. Make sure I put, yeah. Okay, so what do we need to do? Obviously, we just went over the tangent line. So we're going to be using the derivative. So let's find the derivative. And the derivative, f prime of x, is just 1 over 2 root x. You can do that by the power rule, or you can just memorize it. Okay? And here's the formula that we're going to be using. The L of x, which is the linear approximation of some, number, is equal to the derivative times x minus c plus f of c, where c is just some constant, and it's the point that we do know. It's, in this case, 9. The c up here was 9, and it's going to be the c down here. So c is equal to 9. Just remember that. C is the point close enough to the actual point that we want to know that we're going to use the tangent line on to pretty much guess. And notice this is essentially the point slope formula, and if you rearrange everything. And indeed, that's exactly where the idea comes from, is because we're going to use the slope of, or the equation of this line to pretty much guess where we're going to be at. So let's say I want to find f of 10. This is my question. So we know the derivative, we know f of 9, so let's figure things out, okay? So in pink, I'm going to write down everything that we know. F of c, which is f of 9, is equal to 3. f prime of c, which is equal to f prime of 9, is equal to 1 over 2 root 9, which is equal to 1 over 6. And we know, of course, that x minus c, well, this is essentially just the equivalent of x minus 9, okay? So using this information, plug it into the formula right here. So L of x is equal to f prime of c, which is 1/6, times x minus 9 plus f of 9, which is just 3. So this is our linear approximation line. Now we're going to use this now we're going to plug into this equation the 10 that we want. We're going to approximate 10. So once you have this equation, which is going to be what tells you the approximation, we will say, and in the AP Calculus section, especially if it's an FRQ, you would write f of 10 is approximately the linear approximation at 10, which is equal to 1/6 times 10 minus 9 plus 3, which this is just equal to 1/6 plus 3, and this is just equal to 19 over 6. And so f of 10 is approximately 19 over 6. And this is the idea of linear approximation. It's pretty straightforward once you get the gist of it. This is how you do linear approximation, and it's very useful in the AP Calculus, particularly the AB exam. And so just get the idea that we're taking a point that we know around the point that we want to know to approximate, and we're going to use the tangent line at that point that we do know, which in this case was 9, and use it to guess what 10 is. And indeed, you can definitely check it out that. So I'm going to pull up a calculator here. So let's pull up a calculator, TI-84. So we go to a calculator here, and we see, wow, it's not running. There we go. So we say the square root of 10 is this, and our linear approximation was this. So it's pretty freaking close, right? And that's what we want to know. So we just used the tangent line over here. We used all the information we knew about the tangent line, about what we know, to pretty much guess what f of 10 would be, which we don't really know. Square root of 10, yeah, it's square root of 10, but what does that really mean in terms of what number is that, right? 3.16227, it's and on and on and on, but there it is, guys. So that is linear approximation. I hope that helped you guys out a little bit for your AP Calculus classes, or if it's just for your curiosity or for any other calculus or math class. That's it for this video. Leave a like, subscribe if you want to, and I will leave you there. See you guys later.